Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 746, minimum cost climbing stairs. So you are given an integer array cost where cost of I is the ith step on the staircase. Once you pay the cost, you can either climb one or two steps. You can either start from the step with index 0 or step with index 1. Return the minimum cost to reach the top of the floor. So this is what the problem statement is. Now, for example, this is the array. Now, in these staircases, okay, which is efficient for my path is I'll be choosing this 15 only. See, we can start from the 0th index or the first index. Let me start from the first index. So which is equal to 15. Okay, then I'll be doing two steps ahead. Two steps, which means I'll be going one step to 20, then another step to the top of the steps. Can you understand this? Yes. Another way of going to the top stair is, first of all, take this 10, then take this 15, then go to the top, or take this 10, go to 20 and go to the top, or you can go from 15 to 20 then to the top. But there is no purpose, right? Because 15 is fair minimum. That's the reason why we will be just returning 15 as my answer. Hope you understand this. Now, I want you to understand some more things also. Okay, so what is the logic behind it? Okay, now this particular logic is wrong, but still we will be seeing why it is wrong. Okay, so we can go with the greedy approach. Okay, whenever we are seeing some problems that has a minimum or maximum, then we will be going absolutely towards the greedy problem, right? Now, using the greedy approach, how we will be encountering this problem? So I will be starting either from 0 or 1, either from 0 or 1, and I can either go to one step ahead or two step ahead. So I'll be checking which is minimum, then I'll be going there. Can you understand this? So the first approach is, let me copy this, it will be useful for me in future. So the first approach is, the first iteration is, I will be starting from here. Now cost is equal to 1 as of now. Then I can either go to this 2 or I can go to this 10. Yes. Okay, what is minimum? Go to 2. Okay, plus. Now I am standing this particular index. Now I can either go to this 10 or go to this 8. What is efficient? Go to 8 because 8 is minimum, plus. Now from this 8, whether I can go to 7 or 2, I'll be going towards 2 because 2 is minimum, 2, plus. Now I am standing here. Whether I will be going to the 3 or top of the staircase, I'll be going towards the top of the staircase. So I don't want to do anything. I have reached the top. So stop there. Now tell me what is the value? It is 13. What is the another approach? Another iteration. The another iteration is, we can start from first index. So let me start from this first index. So cost is equal to 2 plus. Now I'll be going towards this 8 plus. Now I'll be going towards this 2. Then I'll be going to the end. So which is equal to 12. So 12 is lesser than the 13, right? So from my conclusion, I can tell you that, hey, start from the first index. Okay, what is my algorithm? Start from the first index, or start from the 0th index and go to the minimum among its first step and second step for all corresponding indices. Okay, similarly for the starting from the first index also, take the minimum among them. That's it. Fine. So this is going to be the greedy algorithm. And tell me what is the time complexity? It will be O of n, and space complexity will be O of 1. But it fails. Okay. So here I want you to understand why it is failing and why we are not taking the greedy algorithm. Then what is the alternative choice to solve this problem? That's the reason why I have taken this algorithm. Okay. Now see this example 0, 1, 2, 2. Now using my greedy algorithm, I'll be starting from this 0. Okay, 0th index. So 0, 1, 2, 3. So I'll be starting from the 0th index. So cost will be 0. Okay. Either 1 or 2 is minimum, because here 1, here 2, right? Which is minimum? 1 is minimum. So I'll be going towards 1. So plus 1. Now in this 1, whether I can go to this 2 or this 2, both are same. Go to the fairest 2. That's going to be a greedy algorithm, right? So I'll be going to this 2. this 2. Okay, now plus 2 is equal to 3. Fine. Now it's time to start from the first in this element. So let me again do this. Okay, now first in this element is this 1. So cost is equal to 1 plus where I'll be going? I'll be going to this 2. That's it. Then to the top of the staircase. So it's equal to 3. So what is the minimum among them? It is 3. So this is the output we got using the greedy algorithm. But take for example, this is the array, right? Now start from the 0th in this, go to the second in this, then reach the final top. Okay, so here it will be 0 plus 2 is equal to 2. So 2 is the expected answer. But we got 3. So here itself I can tell you that greedy algorithm fails. Okay, whenever greedy fails, which means it implies, hey, go and try all possible combinations. What is all possible combinations? Recursion. Can you understand this? So now we are getting into the recursion, and in further cases we may try to optimize the recursion. Fine. So how I am going to write the recursion for this? So whenever we are writing a recursion, I want to focus on what is the parameter of that particular function. So what are all the varying parameters that are going to be held there? You understand this? Okay. So for example, 0, 1, 2, 2. So let us take this example, because this example only failed in greedy, but it should be passed in any other approaches, right? For that reason I have took this example. Let me take this and copy it. It may be useful in future. Okay, fine. So what is the varying parameter I will be giving inside the function? So it's going to be the index. Can you understand this? I will be standing at this particular index or this particular index, wheresoever I want the index alone. So f of index. So where should I start? Always remember, when you are going for a recursion, always go with the last index to the first index. Always go from the final to the start, which means here what are all the final? First let us clear with that. So I can tell you n minus 1. If the length of this array is n, then n minus 1 is one of the final, and n minus 2 is another final. Why I am telling these two are final? Because from n minus 2 I will be going 2 steps to reach the top. From n minus 1 I will be going 1 step to reach the top. So from here I can tell you clearly, we are going to start from n minus 1 and n minus 2 and go up to the 0th index such that whichsoever minimum, that's going to be my answer. I know you cannot understand this by verbally. I'll be executing here. Okay, so in first case I'll be starting from n minus 1. So n minus 1 means 3. Okay, so f of 3. Fine. Now for this f of 3, whatsoever recursion call I can go. So I'm standing here. Okay, if wherever I am in my previous step, so that I'll be reaching the third index. Can you understand this? So for example, if I am standing at the first index, I'll be going 2 steps to reach the third index, or I may stand in my second index such that I'll be going 1 step to reach the third index. So I can tell you that it to come to the third index, you may be in the second index or first index in my previous thing, in a previous step, right? So what are two recursion call I'll be making? One is f of 2 and another one is f of 1. Now let us discuss about the base condition first, okay, so that it will be more helpful. So what is going to be the base condition or the stop condition to stop this recursion? See here, if I am standing here, okay, I'll be starting from where? I'll be starting from 0, or I may start from 1 also. So these two going to be my base condition. Can you understand this? So what is going to be my base condition is, if my this index value is lesser than or equal to 1, then I'll be returning that particular cost of I. That's it. So these two going to be my base condition. Okay, now here it is f of 1. F of 1 means what should be my base condition? It is, I'll be returning this 1. That's the cost, right? So I'll be returning 1. Okay, now for f of 2, I again go for f of 1 and f of 0, 0. Yes. So f of 1 will return 1 and 0 will return 0 because here cost of 0 is 0 and cost of 1 is 1. That's the reason why it is returning. Now observe this carefully. This is going to be important. Okay. Now in my left recursion, it is returning 1. Meanwhile, in my right recursion, it is returning 0. Which should I take? I should take the minimum. Can you understand this? I'll be taking the minimum. Okay, what is the minimum? Minimum is 0 plus. What is the second in this element? Second in this element is 2. So from here, I will be telling 2 plus 0. 2 plus 0. What it implies? It implies, hey, 2 is myself and the minimum path, the minimum cost to come to me is 0. So that's the reason why it is 2 plus 0. So it will be returning 2. Now in my left recursion, it is returning 2. In my right recursion, it is returning 1. Which should I take? I'll be taking this one. Okay. So 1 is minimum. So 1 plus, what is the f of 3? F of 3 is 2. 1 plus 2 is equal to 3. So 3 is returned when I am doing a function call for f of n minus 1. Now it's time to do n minus 2. So f of n minus 2, and this is going to be the array, right? Now quickly. So n minus 2 means f of 2, right? For f of 2, there is only two things. One is f of 1 and another one is f of 0, where both are base conditions, and f of 1 is going to be 1 and f of 0 going to be 0. Now what is minimum among them? 0. So 0 plus, what is f of 2? F of 2 is 2, which is equal to 2. So 2 is returned. Now tell me, f of n minus 1 is equal to 3. F of n minus 2 is equal to 2, which is minimum among them, 2. So 2 is going to be my output. Can I understand this? Yes. Now tell me, what is the time complexity? So I can tell you that time complexity will be O of 2 power n and space complexity will be O of n because of the recursion stack. Yes, again, if you don't know about the recursion stack, recursion tree, just go and watch my recursion introduction playlist. I'll be giving that playlist link in the description. Okay, just go and watch it and continue this video so that you can understand and you can write your own recursion code also after seeing those videos. Okay, now let us see the code for this, then we can go and continue with the optimization techniques. So I have taken the Java code. If you want C++ or Python code, you may just see in the description, and this is the greedy algorithm code. Okay, I'm not going to explain this, but if you need, you can just see this in my solution in the description. Okay, fine. Now this is going to be the recursion code. See here, first n is equal to cost dot length. Now I will be returning what is the minimum among the recursion function. Inside the recursion function, I am passing n minus 1 and n minus 2. So whatsoever the minimum among these, I'll be returning it as an answer. Now inside my recursion function, what I'm going to do, if I is less than 0, then I'll be returning 0. If I is equal to 0 or equal to 1, then I'll be returning the cost of I. Can you understand this? So here, this condition, see here, I. So always the index value cannot be going beyond the minus value. Okay, in the question also, and also here also it is not the possible case. So we can remove this. It will be fine. Okay. So let me comment this and let me run the code. So after that, I will be returning the cost of I plus the minimum among the recursion of I minus 1 and I minus 2. So these are the steps. Okay, these and all you know, right? Now let me submit this so that you can check how the time complexity error arises. Okay, here the time complexity error arises because the time complexity is what? 2 power n. Can you understand this? 2 power n. But the input size is what? Input size will be 1000. 1000 means what? 2 power 1000, which is equal to exceeds the 10 power 9, the clock time. Okay, that's the reason why it is not passed. It is showing time complexity error. Okay. Now we want to optimize it. Whenever it is showing the time complexity error, we want to optimize it, right? So to optimize it, let me take this code, and with the help of this code, I'll be optimizing the code. So see here, this is the recursion code, right? Now I'll be showing you how we are going to optimize, so that please pay attention so that you can understand this clearly. Okay, now we are getting into the second thing called memoization. So before getting into the memoization, you want to know what is memoization, right? For example, if I am going for f of 5, okay, then this f of 5 will be f of 4, f of 3, and this f of 3 will be f of 4 will be f of 3 and f of 2, and again here it will be f of 2 and f of 1, and again here comes f of 1 and f of 0, again here f of 0 and f of 1, again here f of 2 and f of 1, again here f of 1 and f of 0. So this is how it will be recursion call will be, right? Now understand this. Always my recursion will be a DFS approach. It will be going via like this, then come up, then like this, then come up, then come up, then go down, come up, like that, because of the recursion stack. Recursion stack nature is what? Depth versus traversal, right? So if you already saw my recursion introduction video, you can understand this, right? Okay. Now see here carefully. When I encounter this place, this function will be returning some value, right? I will be storing that in my memory, so that when this particular function occurred again, I will not be going again for a recursion call. Instead, I already stored in the memory, right? That itself I will be returning here. Can you understand this? Okay. So this is the use of the memoization technique. Now hope you understand why we are studying about the memoization and why we are doing the memoization for optimization technique, right? Okay. Again, for memoization we can do in two methods. One is using hash map, another one is using array or n dimensional array in specific manner, array or matrix, okay, based on the varying parameters. Okay, so hash map is so simple and it is easy. Just try by yourself. Now I am focusing on array and matrix. Okay, so see this approach and try this hash map approach by yourself. Okay, it's going to be very simple. Okay, fine. Okay, the first step is designing the array. How my array looks like. Okay, just see here in this recursion function, this I is only the varying parameter. Varying parameter means it changes at with time. Okay, so varying parameter is only this I. So I can see there is only one varying parameter, so that I'll be designing 1D array. That's the first step. Okay, now I have a 1D array. Now what is the size of the 1D array? That's the next question I have. I will be coming up, right? So what are the ranges of this I? This I will be from 0. This is going to be the lowest point, right? And it will be up to n minus 1. So from here I can tell you the array is of size n. For example, if the array is the given array, input array is of size 4, then this array will be also the size of 4. Now the next question that arises is, what should be my value inside it, right? So the value can be a default value like null or none or minus value also. See here, whatsoever value that doesn't return here in my function. So here it is returning 1, 0, 2, 3 up to infinity, right? So there are 0 and its positive numbers, right? So you can initialize like -1 or you can initialize like -2, or you can initialize like -3 or any negative numbers, or you can also initialize like null also. That's your wish. Okay, but the initialized value should not be equal to the any of the return value of the particular functions. Recursion call, right? Okay, so that's the second step. So here I'll be mentioning this as null. That's my wish. Okay, and when you are writing the code, that's your wish. Okay, you can initialize with any of the numbers, but that should not be written by any function call. That's the only condition. Okay, now what is the next step? The next step is we are going to update it and we are going to add it in the base condition. What it means. So here the base condition, another base condition is just call this array as memo. Okay, the variable name of the array is memo. Now After this base condition, I want to add another base condition, like if memo of I is not equal to null, then I'll be returning memo of I. Now you cannot understand why I'm doing this particular line. Now you can, after I'm explaining another line, you can understand this clearly. Now this particular line, instead of this particular line, I want to write like update it first. So memo of I is equal to cost of I plus math dot min of, so these all lines will be here. Okay, then return the memo. So what I'm doing here, I will be updating my array in each and every recursion call, and then when the particular function again occurs, I'll be just returning it. That's the line, this line doing. Okay, and this line is updating, and this line is base condition. So now hope you understand how we are doing a memoization technique. By doing this memoization technique, can you tell me what's the time complexity? Time complexity will be O of n. Why it is O of n? Because you can clearly see here, when I memorize everything, okay, there is no repetition of any functions. So the function call will be from 0 to n minus 1. So there is no duplication. So there are only n number of recursions, right? So that's the reason why it will be O of n, and space complexity will be also O of n, because there are two reasons. One is the auxiliary array we have taken here, okay, and also the recursion stack. So these are the two reasons for the space complexity. Okay, and also here you can understand this clearly, right? Okay, if you have any doubts, just comment in the comment section. Okay, I will be just giving the answer for it. Fine. Now let us see the code for this. The same thing I written in the drawing explanation also. See here, this is the code. So same thing. First of all, I will be initializing the array. Okay, and then here I will be adding whether that array is not equal to the null. Then I will be returning the memo of I. Again, I will be updating the memo of I. Then I will be returning the memo of I. That's it. Now if I submit it, it will be submitting successfully, because see here it is O of n approach. Okay, if you use the hash map approach, it will be O of n log n. That also will be submitted here, because the input size is only 1000. N log n will be accepted in a 10 power 5 also, right? So that's the reason why we can also do this in a hash map approach also. That's your wish. Okay, now why I'm telling you to do in a particularly in array approaches, we can further optimize it. Okay, that's the reason why I'm just telling you to do in a array approach. The hash map approach is done when you are going in a competitive programming like Leetcode contest and all. Okay, but if you are going for a technical interview round and you want to optimize your code at the extreme level, then go with this array approach. That's my request. Okay, now see here, we have optimized the time complexity, but we haven't optimized our space complexity. So the first thing I want to remove is this recursion stack. Okay, so remove this recursion stack means what we are going to do, make the code recursion into a looping. Make the code into the looping, which means the next step is going to be tabulation, which means convert the above recursion into a looping, so that my recursion stack will be not there, so that I can tell you the space is optimized slightly, right? So now how my tabulation works. So let me take the code. So this is the code, right? Now there are some few steps to convert memoization code using array into a tabulation code. So observe this carefully. First, take this line, write as it is. So these lines will be same. Okay. Now the second thing is, I want to check whether the size of the array differs or will be remain same. Okay. So before that, see here, if I is equal to 0 or I is equal to 1, what is my cost? What is my returning value? It is cost of I. So I'll be constructing an array at first. of size 4 for input 0, 1, 2, 3. Okay, for this I am just constructing down. Okay, now here 0 in this, first in this, second in this, third in this. What is the base condition? First of all, the base condition is if I is equal to 0 or I is equal to 1, I will be doing I will be returning cost of I, right? So what is the index number 0? 0. So right here also 0. What is index number 1? 1. So put here also 1. Can you understand this? So update this base condition into the memo array. Okay, what is the next step? Next step is just see whether there is any more base condition. There is only one base condition like this, but it is ignored. It can be ignored. Okay, whether any other base condition is there? No, right? So now it's time to go for the looping. So put a for loop for I. I will be from which range to which range? It will be starting from 0. Okay, and it will be ending up to n minus 1, or it will be starting from 1 and ending at the n minus 1. Sorry, n, right? So that's going to be the loop. But here, where my start of I is there, my I will be starting at this particular point. My I is starting at this particular point. What is the point? It is 2. It is 2. So my I is starting from 2 because 0 and 1 are the base conditions that are filled. So always remember, I forgot to tell this, whenever we are changing from a memoization into a tabulation, always remember this step. If in the memoization you are traversed from n minus 2 up to 0, then in tabulation you want to traverse from 0 to n minus 1. So this is going to be important step. Okay, always do a reverse fashion. Okay, that's the reason why we are going from where? From 2 up to n minus 1. Okay, fine. So this is the first step. Okay, what is the second step? So put this line here. How memo of I is equal to cost of I plus math dot min of what is here? Top down. So this function, right? But instead of this function, just write memo of what is the value inside it? It is I minus 1 plus, sorry, comma. What is here? Top down means what? Again do a memo of what is the value here? I minus 2. That's it. Okay. After that, what I want to do? Return. After finishing this loop, return. What is here? Returning memo of I. But here the actual answer is what? Return minimum among n minus 1 and n minus 2, right? So this is want to be written, right? So return minimum of memo of n minus 1 comma memo of n minus 2. That's it. So this is going to be your entire code. Okay, if you have any doubts in this code, just try run with this example or any other example so that you can understand this code clearly. Okay, by doing this, tell me what is going to be the time complexity. It will be O of n, and what is going to be a space complexity. It is also O of n, but it is of only of the auxiliary space, the array. Okay, recursion stack is eliminator. Okay, so this is going to be a time and space complexity analysis. Fine. So let us see the code first, then go to the next optimization technique. So see here, this is going to be the code. So here I have mentioned, like, instead of memo I have given here as dp. Okay, now dp of 0 is equal to cost of 0, dp of 1 is equal to cost of 1. Now I will be starting from 2 up to n. Okay, up to n means what? Going up to n minus 1 inclusively. Okay, now dp of I is equal to cost of I plus math dot min of dp of I minus 1 comma I minus 2. Now hope we understand how we have converted memoization into a tabulation with simple steps. Many of them will be struggling at this particular point, but if you follow whatever step I have mentioned in the drawing explanation, then you can surely just easily change or convert from a memoization into a tabulation. Okay, at last I will be returning whatsoever value we have written in the memoization. Can you understand this? Yes, fine. Okay, now it's time to take this code and still optimize it. First of all, most of the problem will be optimize up to this only, up to the tabulation only. Very few code will be entering into a space optimization area. Space optimization. Why we need space optimization? Still here we have used the array. Now we are going to check whether this array is necessary or not, whether it is a waste space. Not waste space, it is like unwanted space, okay, like that. Okay, now we are going to remove this array. Whether first we want to check whether we can remove this array or not. So see here I have mentioned dp of 0 and 1. Okay, inside here also I have mentioned dp of I minus 1 and dp of I minus 2. So from here I can tell you that we only want previous and previous. If I am standing at the current, then we want only previous and previous. So from this I can tell you I don't want n size array. I only want array of 2 size. For example, if this is the input array, then I want only array of 2 size. Whatsoever the input array may contain 1000. Okay, again I only need array of 2 to do a space optimization. So now what I'm going to do is step number 1. I want to initialize an array. Instead of dp here in this line, I'll be initializing dp like this. Okay, what is the second step? Do this same thing. So cost of 0 will be 0, cost of 1 will be 1, because here 0th index is 0 and first index is 1. Okay, now what is the next step? So write a loop for I will be from 2 up to n. Okay, now inside here dp of I is equal to cost of I, write cost of I, plus here min of dp of I minus 1. Instead of dp of I minus 1, write dp of 1. Okay, comma, instead of I minus 2, write dp of 0. Fine. Now that's it. Again, when I am going to the next iteration, they should be swapped, right? So for that reason, I will be writing dp of 0 is equal to dp of 1, and dp of 1 will be equal to, here dp of I is not present, right? dp of I is not present. So for that reason, take current value as 0 and make this as current, and here make this as equal to current. Okay, at last just return this particular value, which means return minimum among dp of 0 and dp of 1. That's it. So now it is space optimized, and now tell me what is the time complexity. I can tell you time complexity will be over n and space complexity will be over 1. Can you understand this? Let me try run this. Okay, so let me try run this once so that you can understand this clearly. So this is the given array. Now this is our dp array. So initially dp array will be 0 and 1. Okay, now I am standing at particularly at the index number 2. So standard index number 2. Now current is equal to cost of I. Cost of I means 2 plus. So let me write clearly here. Current is equal to 2 plus. What is the minimum among dp1 and dp0? It is 0, right? 0 is equal to 2. Now dp of 0 will be updated as dp of 1. So it will become 1. And dp of 1 will be updated as current. So it will be 2. Okay. Now go to the next index. So traverse to the next index 2. Okay. Again now current is equal to what is the cost of I? It is 2. Plus what is the minimum among dp of 1 and dp of 0? It is 1, right? So 2 plus 1 is equal to 3. Now again dp of 0 is equal to dp of 1. So update this as 2, and dp of 1 is equal to current. So update this as 3. Okay, that's it. At last return the minimum among them. So minimum is 2. So 2 will be my output. So this is the try run code. Okay, instead of using 2 sized array, you can also use the 2 variables also. I will be showing that in the code. Okay, so this code is similar to the Fibonacci series. Slight difference in the Fibonacci series, like we will be adding the cost. That's it. Can understand this? Okay, so this is how we will be taking a huge problem, a recursion problem, and optimizing up to it is wholly optimized. Okay, so let us see the code without no delay. So see here, Here I have initialized previous 2. Previous 2 means my arrays 0th index. Okay, and previous 1 means my arrays first index. Okay, first of all I initialize them. So as I already told you, I will be showing in a variable format. Okay, now I will be starting from 2 up to n, and my current will be cost of I plus minimum among them, those variables, and I will be updating my previous 2 as previous 1 and previous 1 as my current. At last I will be retaining the minimum among them. That's it. So if I submit it, it will be submitted successfully. Okay, because it is running in a O of n, it is submitted successfully. Okay, so hope you understand the entire coding path. Okay, and also the logic behind it. So that's it, the whole program. If you want to know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video, subscribe to my channel. And if you have any doubts, just comment below. I'll be commenting the answers. Thank you.